This is lesson 8.4, and today we're going to talk about angles of elevation and depression. So here's a picture of a pilot in a plane and someone in a radio control tower. And first, let's look at the definitions of angle of depression and angle of elevation, and then we'll come back to this picture. So our objective is to solve problems involving angles of elevation and angles of depression. Our vocabulary is simply angles of elevation and depression. So, okay, fine. What is an angle of elevation? An angle of elevation is formed by a horizontal line and a line of sight to a point above the line. So here's the man in the control tower. And this dashed line here is his line of sight. Is the horizontal line. This line here from T to P is his line of sight, which is above the horizontal line. So that makes angle 1 an angle of elevation. An angle of depression is formed by a horizontal line and a line of sight to a point below the line. So here's the pilot. Here's a horizontal line. And here's the pilot's line of sight from P to T, below that horizontal line. And so that makes angle 2 an angle of depression. Since horizontal lines are parallel, it must be true that angle 1 is congruent to angle 2 by the alternate interior angles theorem. And so 1 is congruent to 2. And we're going to use that fact quite a bit in this lesson. Example 1, classifying angles of elevation and depression. Chester stands at the edge of a very tall cliff. He's probably not very bright. Above, he sees an eagle. Below, he sees a pine tree. Classify each angle as an angle of elevation or depression. So let's classify 3 and 4. So how is angle 3 formed? Angle 3 is formed by a horizontal line and then a line of sight from the eagle to Chester, which is below that horizontal line. And so that makes angle 3 an angle of depression. However, angle 4 is formed by a line of sight, a horizontal line, and a line of sight that goes from Chester to the eagle. And so that makes 4 an angle of elevation. 3 has to be congruent to 4 by the alternate interior angles theorem. Now go back to the picture and see if you can classify on your own angles 5 and angle 6. Go ahead and pause the video. One quick picture. Here's a robot, has his arm horizontal, lifts his arm into the air. That's an angle of elevation. Here's a depressed man with an arm held out in a horizontal fashion. He lowers it. That's an angle of depression. Example 2, finding distance by using angle of elevation. An air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. The pilot reports that the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport? Round to the nearest foot. There will be some problems in the homework you'll be given a word problem and you won't be given a picture. So in those cases you need to draw a picture. So here's a picture. P is the plane, A is the airport. Since 41 degrees is an angle of elevation, the line of sight goes from the airport to the plane. 4,000 feet is the altitude, so that's the height of this triangle. X is the horizontal distance along the ground. So we use our trig function. We set up a proportion. The tangent of 41 degrees over 1 equals 4,000 over x, opposite over adjacent. We cross multiply. X equals 4,000 divided by the tangent of 41 degrees. And to the nearest foot, excuse me, that's 4,601 feet. So it's a word problem, so we finish with a sentence. The plane is a horizontal distance of about 4,601 feet away from the airport. Now try the following on your own. Pause the video. Example 3. Finding distance by using angle of depression. A forest ranger is in a 90-foot observation tower, sees a fire. The angle of depression to the fire is 7 degrees. What is the horizontal distance between the tower and the fire? Round to the nearest foot. So here's our cute little picture. T is the top of the tower. S is the base. F is the point where the fire is, and so X represents the horizontal distance. Now, since the ground is horizontal or is parallel to this horizontal line, that means that angle F must also be 7 degrees by the alternate interior angles theorem. And so we can set up a proportion. The tangent of 7 degrees over 1 equals 90 over x. Cross multiply. X is 90 divided by the tangent of 7. And so to the nearest foot, that's 733. Finish all your word problems with a sentence. The tower is a horizontal distance of 733 feet from the fire. Now go ahead and pause the video and try the following on your own. Example 4, aviation application. A pilot at an altitude of 2.7 kilometers sights 2 control towers directly in front of her. The angle of depression to the base of one tower is 37 degrees. The angle of depression to the base of the other tower is 58 degrees. What is the distance between the 2 towers? Round to the nearest tenth of a kilometer. Before we begin, let's go ahead and look at the picture and make sure we understand the picture. If you can see my cursor, this angle is 37 degrees. Angle QPB. This angle is 58 degrees. That's angle QPA. Now, because of the alternate interior angles theorem, that means that this angle here, PBC, must be 37, and PAC must be 58 degrees. We are being asked to find the distance between the 2 towers, and that's the distance x. But look at triangle PAB. It's not a right triangle. Now, eventually, we will be able to use trig on triangles that are not right triangles, but not yet. So how do we solve this? How do we figure out x? Well, I want you to notice that in this picture, there are 2 right triangles, PCA and PCB. And so we can use our trig on those. Notice also that z is equal to y plus x. And that means that x, the distance we're looking for, is z minus y. So what we're going to do is we're going to solve both right triangles. I'm going to find z, and then I'm going to find y, and I'm going to subtract y from z, and that will give me x, which is what I want. So tangent of 37 over 1 is equal to 2.7 over z, and that makes z equal to 2.7 over 37 degrees. Tangent of 58 over 1 is 2.7 over y, and that makes y equal to 2.7 over tan 58. So, since x is equal to z minus y, I take 2.7 over tan 37 degrees minus 2.7 over tan 58 degrees. And to the 10th, that's about 1.9 kilometers. And so the towers are about 1.9 kilometers apart. All right, go ahead and pause the video and try the following on your own. Luke 21:28. But when these things begin to take place, straighten up and lift up your heads. That's an angle of elevation, because your redemption is drawing near. God bless you, wherever you are today.